our section of 5.7, equations and inequalities with rational numbers, we're going to be dealing with solving problems with rational numbers and with decimals, and also solving word problems. So in our first example of problem solving, we're going to be solving an inequality with fractions. A sign in a clothing store says to take 1/3 off the marked price of a shirt. You have $20 in cash and a $5 gift certificate. What are the original prices of the shirts you can afford? So in an example like this, we need to understand that anything that we purchase has got to be less than or equal to $20. So we're going to take our original price. Then we're going to subtract the 1/3 marked off on their special. Then we can also subtract the $5 gift card that we have. Now notice, you might think that you can add the $5 gift card to the cash that you already have to make it $25, but how I'm setting it up is showing each of the examples that were in the actual word problem. We will be adding the $5 to the $20 in just a minute. So the first thing you're going to do here is you're going to combine your like terms. So recall, there's an understood 1 there, minus 1/3 x. If you need help, you can also change that to 3/3 minus 1/3 x. Once we simplify that, we have 2/3 x. And let's bring down the rest of the problem. Minus 5 is less than or equal to $20. Now, as we've been using in previous examples, we're going to add 5 to each side of the inequality. So now we have 2/3 x is less than or equal to 25. And then using our multiplicative inverse rule, we're going to multiply each side by 3/2. X is going to be less than or equal to 75/2. Now, please note that the question is asking what are the original prices of the shirts you can afford. So we're going to need x to be less than or equal to a decimal. So if you take 75 and divide it by 2, you get $37.50. In example 2 of problem solving, Katie has $50 to spend on tulip bulbs for her new garden. Her husband has given her a gift certificate for $25 for bulbs. For this week only, the garden catalog she orders from is offering 1/5 off the price of any order with no shipping charges. What is the total of the original price of bulbs that Katie can afford to buy? Now, this problem is similar to the previous one. So I'll pause the video, let you set it up, and to determine what is the amount she cannot go over for her bulbs. In this example, you should have set it up similar to the previous one. You cannot spend any more than $50, so it has to be less than or equal to $50. So you take your original price and you should subtract. This should be x minus 1/5 x because it is a discount. So x minus 1/5 x minus your $25 gift certificate. All that should be less than or equal to 50. So I simplify x minus 1/5 x, and I get 4/5 x minus 25. Then I add 25 to each side. So now I have 4/5 x is equal to 75. I multiply times each side times the multiplicative inverse because my goal is to isolate the variable. So 75/1 times 5/4 is going to equal to 375/4. Again, I need to determine how much money I do not want to spend more than, so I needed a decimal in my answer. So x has got to be less than or equal to $93.75. Okay, now in your homework, in your textbook, They are asking you to solve inequalities by clearing the fractions. They call it clearing the fractions. We're going to do the same thing we've always been doing, is trying to isolate the variable. So we're going to do inverse operations. So when you're asked to clear the fractions, it just means you're trying to isolate the variable and solve for the variable. So in this example 3, we'll add 1/8 to each side. So now we have, it's -3/4 m is less than or equal to -1/8. Then we're going to multiply each side by the multiplicative inverse. Simplify. Now, I'm going to multiply each side by -4/3. So as you recall in previous lessons, when we multiply or divide by a negative number with an inequality, you reverse the inequality. So your final answer for example 3 would be m is greater than or equal to +1/6. In example 4, I'll pause the video, we'll work it out, and check our answer in just a minute. Now, in this one, we are solving an equation by clearing fractions. We'll, of course, move the constant first, so we'll be adding 3/8 to each side. So we will have 3/4 plus 3/8 is equal to 6/8 plus 3/8, which is equal to 9/8. Now we have 7/16x is equal to 9/8, and we're going to use the multiplicative inverse. 16/7 times each side. We have x is equal to 18/7. Then we simplify that to 2 4/7. Always check your sign to make sure that it is a correct, either a positive or a negative. In this example, solving equation by clearing the decimals, again, we do the exact same as we do in fractions, which is our rational numbers. We do the inverse operations. Remember, when you are dividing with decimals, that the divisor needs to be a whole number. So I'm going to pause this. Let us work this out and come back and check our answers. On this example with decimals, we move the constant term over first, so we would subtract 5 and 1400 from each side. When we do that, we have -2 and 8400ths on the left-hand side is equal to 8/10 in. Doing the inverse operation, we divide each side by 8/10. Once we do that, we recall that we needed to move the decimal over in the 8/10 one, so what we do to the divisor, we have to do the dividend. Be very careful as to put the decimal in the correct place. After we divide that, we get 3 5500ths, and the answer will be -3 5500ths. Clearing decimals, again, another example. So I'll pause this. We'll work it out and come back and check to see what b equals in solving the equations by clearing the decimals. Again, checking, we're subtracting 3 6400ths from each, we're adding 3 6400ths to each side for the inverse operation. And we're dividing each side by 2 and 2/10 b. Final answer is b is equal to 5 and 5/10. Now, in these examples, you will not have to graph in your homework, but you're going to have to be able to determine if a certain equation equals a certain graphing on the number line. So, in this example right here, in order to solve this inequality, we're going to add 1 to each side. So now we have s is greater than or equal to 5. So I'm going to graph this by finding the 5. It is going to be a closed circle because it is including the 5, and the arrow is telling me which direction to graph it. In the second example, I'm going to add 3 to each side. Now I have 7 is less than b, but because I like the variable to be on the left-hand side, I'm going to say b is greater than 7. Going to find the 7 on the number line. It is an open circle because it does not include the 7, and graphing it just like that. In our last example, subtract 1 from each side. W is greater than -2. Going to find the -2, open circle, and to the right. Okay, let's solve for this inequality and graph it. Multiply each side. Multiplicative. So I'm going to multiply each side by 3/1. X is going to be less than or equal to 12. Now I'm going to go this. I did not have a 12 on here, so I'm just going to extend this number line right here. And X is less than or equal to 12, so it's going to be a closed. Just follow it all the way down. Now on this example, we're going to solve the inequality by multiplying each side by 8. X is going to be greater than -64. This one, if you're ever asked to actually plot it on a number line, just draw a number line, plot the -64, and a number that will come before, and a number that will come after it. It's greater than, open circle, to the right. And on our final answer, we're going to divide each side by -1. When I divide by a negative number, I'm going to reverse the inequality. So I have n is less than or equal to 10. So on this one, I'm going to do a closed circle on 10. And going to go all the way.
Also, we need
I'm going to pause, let you work the challenge, and we'll come back and check the answer. In this challenge problem, we used the distributive property. We distributed 2/3 to everything inside the parentheses. 2/3 times 18, which is 12. 2/3 times 1/3 x, which is 2/9 x. And then we brought everything else down. It's equal to 1/9 x plus 5. Then on this example, we subtracted 5 from each side of the equation. Then we ended up with 7 plus 2/9 x is equal to 1/9 x. We subtracted 2/9 x from each side, which brought us to 7 is equal to -1/9 x. In order to isolate the x, we multiplied each side by the multiplicative inverse, 9, -9 over 1. And then -9 times 7 is -63. So x is equal to -63.